Greetings and welcome to Teaching Math in Elementary Schools. Remember the important dates that are on the screen. September the 11th, lesson plan. September the 13th, your reflection. September the 20th, your lesson plan. September the 27th, your second reflection. In your email, you were given an article entitled Teaching Children with ADHD. As an educator, as a future educator, you will deal with a variety of students of different demographics, socioeconomic status, academic levels, religious beliefs, and cultural differences. Several million children with ADHD in the United States, they constitute about 3 to 5% of the student population. They exhibit several behaviors: fidgeting, difficulty remaining seated, blurting out answers, shifting from one activity to another, losing things. Other behaviors include wide range of mood swings, failure to give close attention to details, and avoiding careless mistakes. There are two main categories of these type of students. They have poor sustained attention and hyperactivity, impulsiveness. Teachers who are successful in educating children with ADHD use a three-pronged strategy. Identify your students' needs, select different educational practices associated with academic instruction, behavior interventions, and accommodation. Combine these practices into an IEP or individualized education plan. On the screen, you will see other several practices that are successful in dealing with children and teaching children with ADHD. You can review previous lessons, state needed materials, simplify instructions and choices and scheduling, be predictable, use audiovisual materials, ask probing questions. Also, help students correct their own mistakes, help them to focus and follow up directions, lower the noise level, divide work into smaller units. As an educator, I used to, if I gave students a whole page of math, I would tell my special ed students, just do the odd problems or just do the even problems. Use cooperative learning, use assistive technology. In teaching language arts and reading comprehension, children with ADHD will benefit from the following: silent reading time, follow along reading, storyboard, storytelling. Also, board games, computer games, recorded books. When you teach phonics, word families, and games, picture letter charts. In teaching writing, recognizing parts of a story, have a post office activity, tape recording, dictation. For math, teach them patterns, team them up with a partner, have them a mastery of math symbols, real life examples of money skills, color code arithmetic symbols, board and computer games. Now we're going to look at a lesson in which The math teacher is teaching her students about congruence, transformations, and similarity in math.
So I'm going to have us do a little activity together if we can. So I'm going to tell you what materials to go find, and then I'm going to have you pause the video, and when you have them, come back, okay? So you need some type of marker. It can be a pencil, a pen, or a color pencil, a crayon, whatever you want, but something to write with. You need some scissors, and you need some type of paper that you can cut apart. Okay, so if that's just a blank piece of white paper, it could be notebook paper, it could be some piece of random recyclable paper, whatever you need. So you need some type of writing utensil, scissors, and a piece of paper. So go ahead and pause the video and go get those and come back. All right, we're gonna get started now. So the first thing you're gonna do on your paper is I'm gonna have you fold it in half. So we're gonna fold it hamburger style like this, okay? And then, if you want to make it as perfect as you can, but it doesn't have to be, okay? And then you're gonna fold it in half one more time. So it's kind of gonna look like a little card. Okay, so it'll be about this size, okay? Like that, okay? Then once you have it like this, you're gonna draw some type of two-dimensional polygon. So I'm gonna choose to draw a triangle, but you could choose to draw a circle, a square, a hexagon, a trapezoid, whatever you would like. All right, so I drew a triangle on mine, just like this. Okay, then I want you to cut out your shape all the way through the piece of paper, okay? So I'm gonna take my scissors and I'm gonna cut it out, just like this, okay? And so now I want you to see that there's not just one triangle. You actually have 4 triangles, or whatever shape you drew on your piece of paper, okay? So we have 4 figures now, okay? Are all of the figures the same size? Yeah, they are, because if we put them all on top of each other, none of them are sticking out or overlapping, right? They're all the same exact size, okay? All 4 of them, okay? Are they all the same shape? Yeah, they're all triangles, right? So I have 4 triangles that are the same size and the same shape, okay? How do we know? Because they all match, right? We just said they all line up together when you stack them up on top of each other, okay? So that is kind of what it means when a shape, that is what it means, not just kind of, it is what it means when a shape is congruent.
Hello all, welcome to Math for Juniors with me, Miss Marks, and my assistant Snail. Who apparently is not around, but never mind.
Hi everyone!
Oh, Snail, there you are. Thanks for coming on time. You're just 5 minutes late for the session.
Oh, just 5 minutes? Not bad.
Now, will you care to tell me why you are late?
I was studying math. I thought I will study about today's topic, and I got so involved that I forgot I was late.
You were studying math. Today's topic. All right, then why don't you tell us something about congruent figures?
Congruent figures? What's that?
You said you were studying today's topic.
Yes.
And you don't know about congruent figures, which is today's topic?
Okay, Miss Marks, I am so sorry. I overslept and that is why I am late. Please don't get angry and don't mark me absent, please.
Some things can never change.
I am sorry.
All right, since you have no clue about congruent figures, why don't we go and check out about it in the virtual world? Objects which have the same shape and size are called congruent figures. The mathematical symbol used to denote congruent looks like this. Now, let's look at condition of congruency of line segments. Two line segments are congruent if they have the same length. The line segments AB and CD are of equal length, thus AB is congruent to CD. Now comes the congruency of angles. Two angles are said to be congruent if they have the same measure. Thus, angle ABC is congruent to angle PQR, means that measure of angle ABC equals to measure of angle PQR. So, Snail, did you understand the concept of congruent lines and angles?
Yeah, somewhat.
Alright, then before going into the other condition of congruency of other figures, let's do an interesting activity. Here is an A4 size piece of paper. Now, let's fold it in half.
What now?
Now spill a few drops of various colors ink on one half side.
Okay, let me put a yellow drop, a blue, and a green drop.
Now press the two halves together and then open the sheet.
Wow! I have obtained a beautiful design. Miss Marks, aren't the designs on the two halves congruent?
Yes, Snail, they are. We can cross-check it by cutting along the edge of the pattern of one half and then putting the cutout on imprint.
Wonderful! The cutout design completely covers the imprint on the other half.
See, I told you math is fun. But for now, enough for fun. So, it's the time to go to the virtual world and learn more about congruent figures. Two circles are congruent if they have the same radius, that is, circle C1 is congruent to circle C2, if the radius of C1 equals to radius of C2. Here comes squares congruency. Two squares are congruent if the length of their sides are equal. Thus, square ABCD is congruent to square PQRS if AB is equal to PQ. Similarly, congruency of rectangles implies that the rectangles have same length and breadth. That is, rectangle ABCD is congruent to rectangle PQRS if AB is equal to PQ and AD is equal to PS. So, Snail, why don't you give me a few examples of congruent objects that you see around us? Oh, what have you done?
Oh, sorry.
You are so clumsy.
Sorry. Looks like a sorry day for me. Yes. Oh, yes.
Now what is that?
I got an example of congruent figures. A4 sheets.
Well, that's a right example. But I don't think it required that dance.
Oh, I got carried away.
Okay. Give another example.
Another? Not fair. Okay, let me think. How about ATM cards?
Take my ATM card and see.
Let's see. See, they completely cover each other. So yes, they are congruent.
That reminds me that even the CDs are congruent. See?
Oh, what are these, Miss Marks?
These are pictures of...
Eiffel Tower. I always wanted to see them. Where did you get these pictures from?
I will tell you about them later. But now is the time to go to the virtual world and learn more about congruency. Two triangles are congruent when you can superimpose one triangle on top of the other. Note that for triangles to be congruent, the corresponding paths should be congruent. The corresponding line segments should be equal in length and the corresponding angles should have equal measurement. The side AB corresponds to PQ, BC corresponds to QR and AC corresponds to PR. Similarly, angle A corresponds to angle P. Angle B corresponds to angle Q and angle C corresponds to angle R. In other words, the corresponding line segments are equal in length. Similarly, the corresponding angles have equal measure. You have to be careful while comparing corresponding parts of triangles. Here, triangle ABC is congruent to PQR, but triangle ACB is not congruent to triangle PQR. I see you are quite fascinated by the pictures. Do you notice something about them? See?
Yes, they are the same pictures in different sizes.
Correct. They are developed from the same negative in different sizes.
Oh, so are they congruent?
Oh no! Since they are of different sizes, they aren't congruent, but they are similar.
Oh!
But you know something? The Eiffel Tower is actually made of congruent triangle structures.
What? Congruent triangles in Eiffel Tower?
Yes, math is everywhere. Why don't we check out more about this? The tallest structure of the Eiffel Tower, designed and created by Alexandre Gustave Eiffel, has a basic structure of a truss.
Truss? Earlier you said it is composed of triangles.
Well, Snail, truss is a structure composed of series of open triangles, all congruent or similar.
Open triangles? What's that, Miss Marks?
By open triangle, I meant the triangles with just the boundaries and nothing in the interior, or the hollow triangles. The tower in total is composed of 186 such triangles.
But why is it so? Does these open triangles make it look beautiful?
No, that's not an engineer's thought. A.G. Eiffel knew that if his bridge was made of thick, solid wrought iron beams, it would be very heavy and the beams would rattle in the wind. But if he used a series of open triangles, the gusty wind in the valley would blow right through them.
Okay, that means truss pattern made it lightweight and thus to withstand the wind.
Not only that, the truss made it stable as it is composed of the most stable polygon, the triangle. A push on one segment is resisted by an opposite pull from another, all along its length. So the bridge remains strong and rigid despite its lightness.
That is so incredible!
Now it's the time for us to take a quick memory jog. I'm going to press the recap button and quickly go through the main points we have learned today about the congruent figures. Friends, pay proper attention. Today we have learned that figures which have same shape and size are called congruent figures. Two line segments are congruent if they have equal length. Two angles are congruent if their measures are equal. Two circles are congruent if they have same radius. Two squares are congruent if their sides are equal. Two rectangles are congruent if they have the same length and breadth. Two triangles are congruent if the three sides and angles of one triangle are equal to the corresponding sides and angles of other triangle. So, Snail, how did you find today's session?
Except the sorry part, it was quite interesting.
Yeah, lots of sorry in the beginning.
But otherwise, I found it interesting.
What are congruent shapes? Congruent means equal. Congruent shapes are shapes that are exactly the same size and same shape. These triangles are congruent. They are equal. They are the same size and the same shape. Are these shapes congruent? No, these shapes are not congruent because they are not the same size. Yes, they're the same shape, but this is big and this is little. In order to be congruent, they must be equal in the size and the shape. The reason why these shapes are not congruent is because they are not the same size. Are these shapes congruent? No, they are not. The reason why these shapes are not congruent is because they are not the same shape. This is a square and this is a circle. Are these shapes congruent? Yes, they are. They are the same size and same shape. Are these shapes congruent? Yes, they are the same size and the same shape. At first, it doesn't look like the same size, but try rotating it to a different angle. Which figures below are congruent? The answer is A. They are the same size and the same shape. B is not correct because they are not the same size. C is not correct because they are not the same shape. D is not correct because they are not the same size. Congruent means same size, same shape. Here are some more task cards on congruent figures. Number 1. Which figures below are congruent? Number 2. Which figures below are congruent? Number 3. What does congruent mean? A. The same size but not the same shape. B. The same shape but not the same size. C. The same size and same shape. Or D. Only the same shape. Number 4. Which figures below are not congruent? Number 5. Look at the figure below. Which figure below is congruent to the rectangle ABCD? Number 6. Look at the figure below. Which figure below is congruent to the right triangle ABC? Number 7. Which figures below are not congruent? Number 8. Which two shapes are congruent? Number 9. Which two shapes are not congruent? Number 10. Are these two shapes congruent? Are these two shapes congruent? Explain. Are these two shapes congruent? Explain. Here are the answers. Thank you so much for watching and have a wonderful day.
What were the strengths of the lesson on congruent shapes? And how did you feel about the videos, the two supplemental videos that you can use with your students in instruction as an introduction to explain what congruent shapes are? Please type your answer in the chat or send me an email. Thank you. I also used this activity when I was teaching congruent shapes and symmetry, having students to cut out letters and shapes. Now we're going to move on how to teach fractions.
Hi, my name is Ebony Watts and I am K through 12 certified. Today I'm going to talk about teaching fractions to kindergartens. First, before teaching fractions to kindergarten, make sure you describe the different vocabulary words that the children need to know. Explain words such as whole, half, 1/4, etc. Now, I'm going to show you a cool idea of teaching fractions to kindergarten. First, make a whole pie circle on the whiteboard. Explain to the students that the circle means a whole pie. Then chop the pie in half. Explain to the children that the line represents 2 slices, which equals a whole pie that we just chopped in half. Then explain that if we make a horizontal line, then that will be 4 slices of pie. 1, 2, 3, 4. But also explain that if we take the lines away, that it equals a whole pie again. Play around with your pie on the board and let them cut it up to as many pieces as they like. For kindergartens, I will always keep it even amount of numbers so that they can get the concept of equal slices of pie. My name is Ebony Watts, and I just taught fractions to kindergarten.
Kathy, my mascot. In this lesson, we are going to compare fractions. Try to find out which fraction is greater. But first, before we get into comparing, we're going to just review something important, which is, here I have one whole circle, but I divide it into 2 parts, and both parts are colored. What fraction is it therefore? I wrote here 1 because it's one whole, but we can also write it as a fraction. And since there are 2 parts, then it is 2 there, and since 2 are colored, 2 here too. And we read it as 2 halves. How about here? There's one whole rectangle. And how do we write it as a fraction? As you can see, 3 parts in total, 3 are colored, and we read it as 3/3. And over here, we get to comparing fractions, which is kind of fun because you get to color. Okay, what fraction is this? 2/3. And that means I would color 2 of these parts here. And over here, we have 1/2, so I color 1 part. And now we compare which is greater, which is more pie to eat, so to speak. You can think of it as a pie, you know? And so you see, oh, this is more, right? So the alligator mouth goes that way. Over here, 2/3, and what fraction is this? 3/4. So I need to color again. 2/3 and 3/4. And which one is more chocolate bar to eat? You can see over here, this one is a little higher, so that's the greater fraction. Over here we compare 1/3, 1/2. You want to guess which one will be the greater fraction? And once you have your guess, now I'm going to have to divide this here into 3 parts and this here into 2 parts. Like that. And then this one I could divide it this way or this way. But can you see which one will be easier way so we can compare? If I divide it this way, it might not be as easy, so I'll divide it kind of the same way with vertical lines. Now it's time to color. Okay, Matthew, okay, I'll let you color. He's anxious to color too. Sure enough. 1/3, yeah, and then over here, 1/2. Color 1/2, Matthew. Good job. Now, which one is more? This one, of course, so 1/2 is the greater fraction. Notice though that this number 2 is actually the smaller number than the number 3. But it actually tells us into how many parts we are dividing our shape. And so this 1/2 is still, it's more to eat than this. 2/4 and 2/2. Look at this. Have we seen something like this in this lesson already? Over here, 2/2 is the same as the whole pie, isn't it? So I would color the whole pie. Here, I won't color the whole pie. So I can save some time and just tell that this is the greater fraction, right? That's the whole pie. This would be, you know, if I divide it into 4ths and then color 2. Let's go on. Over here. Well, Matti, go back. How many parts is this pie divided into? 6 parts. So each part is a 1/6. 1/6. And let's say that I color a few. Oh, Matthew wants to color again? Well, soon, Matthew. I'll color this time. I colored 3 of those sixths. So I write a fraction, 3/6. And then over here, it's divided into 5 parts. So each part is a fifth. And Matthew, yeah, I'll let you color this time. Okay. Okay. So what fraction is colored by Matthew? 2 parts are colored, 5 in total, 2/5. Oh, here's some more coloring to do. Matthew, come down again. Color this one. 3/5. Fractions are so much fun because you get to color so much. Now it's my turn. What fraction is this? 1/6. So I need to first divide this thing into 6 parts, which let's say I first divide it into 2 parts, like that. And then I go this ways, 2 lines, like that. And then color 1. Over here, 5/5. Actually, that's gonna be the whole rectangle, 1 whole. But I need to still divide it into 5 parts and color 5, so let's try. Oops, those didn't end up being equal parts. Okay, they should have been. So I didn't do a perfect job of dividing it, but I'll color the whole thing anyway. Lastly, we get to compare again. Which fraction is greater? Wanna guess? 3/6 and 1/2. Okay, the 1/2 is already there. Just color it in. And now 3/6. First of all, I will divide this in half. And then with 2 lines like that. Now I will color 3/6. I'll color these 3. Of course, you can color any 3 pieces, but for comparing, this makes it easier. Can you see which one is more? You know, this time they are equal. Right? It's the same amount of chocolate bar to eat, this way or that way. Lastly, again, make a guess. Which fraction is greater? Which part is more to eat? Okay, I'll let you color one more time. 3/5. That much, and 3/4. That much. You can see easily which one is more. It is the 3/4. Okay, was it a surprise? Anyway, we're all done with this lesson now.
Recording in progress.
What were the strengths of this lesson? What were the takeaways? Or perhaps you have criticism of this, either one of these lessons. Please type your answer in the chat or send me an email.
Recording in progress.
Now we're going to discuss how to teach students about geometric shapes. Think a moment about how you learned about geometry in your class as a young student.
Hi, Team Grade 4. Welcome to another edition of Grade 4 Mathematics. I'm your self-proclaimed favorite mathematics teacher, Miss Aaliyah Brewster. Today's topic is geometry, and we're zooming in on lines. But just in case you're not feeling motivated, remember the words of Paul Halmos. The only way to learn mathematics is to do mathematics. So what are you waiting for? Grab a pencil and a notebook, get settled, we're about to start. To begin, we're going to discuss what is a line. That's right, what is a line? A line can be defined as a straight set of points that extend in opposite direction. It has no ends in both directions, therefore it is infinite. It has no thickness and it is one-dimensional or flat. Okay? However, there is a difference between a line and a line segment. A line segment is part of a line which can be defined by endpoints. It has a beginning point and an ending point, as you can see in the picture. Now, boys and girls, there are various types of line. Let's discuss them. The first one is horizontal line. A horizontal line is a line that runs right to left. Okay, so it's a line that runs right to left. All right, there is also vertical lines. Straight lines are vertical if they go straight up and down, or if they go top to bottom without going across at all. So a vertical line would look like this. So you can take your hands and make a vertical line. Okay? Now let's move on to discuss parallel lines. Parallel lines can be defined as two lines in the same place that are at equal distance from each other and never meet. Okay, they never meet. So here are some examples in photographs of what parallel lines look like. So they can go this way, which these are called vertical parallel lines. There's also horizontal parallel lines which looks like this, or what you can see in the photograph, and then there are also diagonal parallel lines. Perpendicular lines. Perpendicular lines are defined as two lines that meet or intersect each other at right angles. Okay, so looking at the photograph, you would notice that perpendicular lines intersect or they meet. Now the point where they meet forms a 90-degree angle known as a right angle. It is shaped like the letter L. There is also diagonal lines. Diagonal is a kind of straight line. A diagonal line does not go straight up and down or across. It is a line that connects two corners of a shape. Okay? It connects two corners of a shape. Here are some examples of what diagonal lines look like. In the second example, you would notice a diagonal line is formed by intersecting or connecting point B and point E. For the final image, a diagonal line connects point B and point C. All those are examples of diagonal lines. Now that we would have discussed lines, it's time for us to have a pop quiz. That's right. You are going to match each term with the picture that it represents. All right. So the terms are line, line segment, perpendicular lines, intersecting lines, and right angle. Good luck. When you're finished, I'll be back to discuss the answer with you. Did you get all correct? Let's verify. Now we're going to match the term line to the red photograph. You notice the arrows are extending out. Remember we said a line is infinite and it goes in opposite direction. So if you match that to that image, then you are correct. Now let's match a line segment. We can match line segment to the blue photograph. Because remember, boys and girls, a line segment is a part of a line, okay? It has a starting point and an ending point. And if you notice in the blue photograph, that line has 2 points, start and end. So it's perfect for that term. Now for the third one, which are perpendicular lines, remember perpendicular lines are two lines that run in the same direction, but they never meet. So we're going to match that terminology to the burgundy or the deep red photograph. The fourth one, which is intersecting lines, we're going to match that term to the dark blue photograph. Notice the lines are intersecting, looking like an X. Those are intersecting lines. Now, the final one, which is the right angle, we're going to match that with the orange photograph, because a right angle is formed when two intersecting angles connect at a point, forming the right angle. So it looks like the letter L. Okay, boys and girls, I trust that you got all of your answers correct. Now, if you did, you deserve a treat. That has brought us to the end of our mathematics lesson. Thank you once again for tuning in, and remember the words of Paul Halmos. The only way to learn mathematics is to do mathematics. This means that you must practice if you wish to be successful at your upcoming exams. Thank you once again for tuning in, boys and girls, and goodbye.
Get in here, let's learn something new today. My name is Teacher Anika, and how are you? You're great? Awesome. I hope you have those books, pencils, and maybe your eraser so that you can start writing your names, also the name of the day and the name of the month. We are going to be doing math, so you can head up for that as well. And let me give you the topic one time. We are going to be looking at measurement. Yes, measurement. So head up, come back here, and let's get started.
Everything feels better when you dance while you sing.
4, today we are going to be looking at measurement. Look at the items on the screen. Have you ever seen those items before? You have? Awesome! So at the top, we have a ruler, and at the bottom, we have a measuring tape. Now, what do we use these items for? Of course, we use a ruler to draw a line. I know that, but we also use it for something else. Who knows? What do we use the measuring tape for? Just to wrap it around us and make maybe a costume or decoration? What do we use these for? We use them to measure things. So for instance, the same line that you're drawing with your ruler, you can use that same ruler to measure the line. If you look carefully on your ruler, grab that ruler and look at it for me. If you don't have the ruler there, I'll give you probably like 5 seconds to run and go get one. 5, 4, 3, 2, 1. I hope you're back. On the ruler, if you look at it closely, you will see some numbers. Do you see them? Great. Then you would see some letters. You would see the letters C and M. Do you see those letters there? Nice. Great. Now, if you have a measuring tape, well, I know mom would have the measuring tape, but not you. On that measuring tape, you will see numbers as well, and you'll also see the letters C and M together. Now, what does this mean? The CM. I'll let you guess, and then I'll reveal what the CM means. CM means centimeter. Centimeter. That's what it stands for. Look again on the ruler. You'll see numbers starting from 0 onwards, depending on the length of the ruler. If you look carefully on the ruler, you'll see the number 0 and then the number 1. But between the 0 and the number 1, you'll see some very short strokes and then a long one in the middle. Do you see those lines? All right. Those lines help you to count when you're doing measurement. All right? Look at the example on the screen. There you can see I'm trying to measure an eraser. How do I know what's the length of that eraser? I put it starting from the number 0 and then check to see where it stops. If I put it at the number 1, I would not be measuring it accurately. We should start from the number 0. And here you can see the eraser, it's measured as 4 centimeter or 4 cm. Now, centimeter is a metric unit of measurement used for measuring the length of an object. And since we're using a ruler, then we're measuring the length of short objects, such as an eraser. If you have an eraser, you can try putting it next to your ruler, starting it from the number 0, and you can check to see what's the length of your eraser in centimeters. Try that. We can also use our rulers to measure various things, like our pencils. Here, my pencil is measured at 14 centimeters. I started with the point at the number 0 and the eraser ended at the number 14. So my pencil is 14 centimeters. Because it's more than 1, I have to put the S at the end of the word, centimeters. Let's look at my crayon. I put my crayon against my ruler, starting from the number 0. When I measure it, it measures 7 centimeters. 7. So my crayon is shorter than my pencil. My pencil was 14 centimeters. but my crayon, it's only 7 centimeters. Now I'm going to move to the kitchen. I want to measure the carrot. Yes, I like to eat carrots because it makes my eyes bright. Do you like to eat carrots? And do you know we can eat this raw or cooked? Great, so I want to measure it. So I put the carrot against the ruler, starting from what number? 2? 1? Great, starting from the number 0. So from 0, when I look, I can see that my carrot is 9 centimeters long. 9 centimeters long. So I can measure various things using my ruler. I can also measure my book. Put my book down on the table, place my ruler next to my book, starting from the number 0, and I can see how long my book is. What about yours? Do you have a long book, a short book? How do you know the length of the book? Rather than saying long or short book, you're now learning how to measure objects with your ruler so that you can say in centimeters. My book is 24 centimeters long, or my book is 10 centimeters long. So you can also try that because I know you have your book there with you and you have your ruler. So try doing it for me. Put the book down on your table, or maybe if you're on the sofa, you can put it on the sofa and measure it and let me know how many centimeters are you seeing. Remember, on the ruler, you would be seeing the letter cm, which means centimeters, or you might be seeing the word of itself. Whichever it is, take your time, ensure it starts at 0, and check to see where it ends. Now, let's do an exercise. I'd like for you to tell me the measurement of the objects you're seeing on the screen. So I've placed the ruler there already, and then I have an aeroplane. Can you tell me the length of the aeroplane? Look carefully. I'm going to give you a few seconds to look at the picture, look at the ruler, check to see the measurement, and then you're going to give me the answer. What is the length of the aeroplane? Now, if we look carefully, we would see the tail of the plane starts at 0 and the nose ends where? That looks to me like 14. What do you think? I think it looks like 14. So we can say the plane, or the length of the plane rather, is 14 centimeters. The length of the plane is 14 centimeters. Let's look at the other object. I have a train there. Can you tell me the length of the train? Take your time, look at the picture, look at the ruler, check to see where it starts and where it ends, and then you can tell me the length. Take a few seconds, and then we're going to look at it together. Now, when I look at the back, it starts at the number 0 and the front ends at the number 10. Therefore, I can say it measures to the length of 10 centimeters. 10 centimeters. See how easy that was? You have to take your time, start at 0 and check to see where it ends. Now, sometimes it might end up between two numbers where we can say 14.5, but we're not going to look at that right now. We're only looking at whole numbers. So the aeroplane was measured at 14 centimeters and the train was measured at 10 centimeters. Now remember, at the beginning, I showed you the ruler and the measuring tape. The measuring tape is a bit longer than the ruler. Let's say I have my measuring tape, just like the one that I showed you on screen. And most time, mommy has this at home. And I want to measure something. Look at the two pictures on the screen and tell me which one is more suitable for me to use the measuring tape that we have at home. Football field or the length of the baby. The football field or the length of the baby. And when we say length of the baby, the height, right? But we know the baby can't stand up. So we're going to use either the tape for the baby or the football field. Which one would be better for me to measure with that particular tape? If you said the baby, you're correct. For me to measure the football field, it means I'll have to have a very longer tape, right? But for now, since we're using the tape at home, which is shorter, we can measure the baby. See? We'll start from the number 0 and see where it ends, so we'll know if it's 24 centimeters, 50 centimeters, because the baby's pretty much longer or taller than the pencil or the crayon. So let me give you some facts about centimeters. First, 1 meter is equal to 100 centimeters. 1 meter is equal to 100 centimeters. Also, 10 millimeters make 1 centimeters. 10 millimeters makes 1 centimeter. Centimeter can be written as cm. The same letters that you're seeing on the ruler. cm. So the next time you see the letters C and M together, you know what it means. And now you can use your ruler to measure almost anything. Of course, that is short. And you can also ask mom to borrow her measuring tape to measure things that are a bit more tall, like yourself. You can measure your height using that measuring tape because it's longer. This is what I'd like you to do for me. You're going to go into the kitchen. You're going to get a potato and you're going to measure it with the ruler. You're also going to measure your pencil, the remote control, and you can also measure your shoes. When you're finished, I'd like you to write those measurements down inside your book, and you can also write the name of the object, or you can draw it if you don't know how to spell it. If mom, dad, or sibling is home, you can always ask them to spell it for you. Remember, the potato, the pencil, the remote control, and also your shoes. Those are the things I want you to measure. Record the measurements, and next time I see you, you are going to reveal those answers to me. You can measure anything else that you want to. You can have endless fun with this, but you have to be accurate with your measurement or else it's going to be incorrect. So if I'm asking you, what's the length of your pencil? And you tell me it's 5 centimeters. But then when I measure it, I'm seeing it's 6 centimeters, then it means that you did not take your time to measure your object. So take your time, start from the 0, measure them, record them, and you can also show it to mom or dad. If mommy has the long measuring tape, you can use that, and you can ask mom to measure your height. And you can record that as well inside of your book. So now you'll get to know what's your height in centimeters. All right? So have fun with it. Until we meet again, this is Teacher Anika saying, stay safe, ensure you read the book every day, and when you're finished with mommy's measuring tape, kindly put it back up. and try not to break your ruler, okay? So have fun until we meet again. Bye, boys and girls.